So I'm Chuck Lukaszewski. I work in the CTO office at Aruba Networks. Been there coming up on 8 years now, and work on a lot of complex RF types of environments. I used to run I built and ran the customer engineering team for quite a number of years, and in that capacity, we began doing all of our initial kind of work in stadiums. Fast forward to today, and there's tremendous interest and demand for high density deployments. So it's a pretty popular topic and a pretty complicated topic, and really happy to be here to talk with you about it today. I do want to make this an interactive session, so feel free, and it's going to be sort of technical, so if you've got questions as we go through, please just stop me and I'll take them in real time. And just a comment for those, I know Keith asked kind of who had certifications earlier, but as you can tell from Matthew's presentation, if you haven't pursued the certifications, or if you have one and you haven't really started writing your friends, your colleagues about getting certified, you should do it, because the technology is only getting more complex, right? And I got my CWNE last year, and I think it is a travesty that we're looking at low triple-digit numbers. When you consider the number of access points that are deployed in this, and I can tell you firsthand from the vendor side how many issues we deal with on a day-in, day-out basis that are avoidable, or at least could be reduced in their impact and their resolution time if we were, if we had kind of an equivalent level of knowledge on both sides of the phone. So we have a responsibility as vendors to help push and promote general industry knowledge to our customers. Customers have an obligation to educate themselves. Consultants have an obligation, right? Everybody here in this room is kind of represented. So this is a great certification, and a lot of it does cover some of the material that you heard about, Matthew talking about, and it'll make you a more effective professional in the field. So please look into it if you haven't. So I'm going to be basically covering 6 topics. I want to start with some kind of level setting discussion about just some terminology that we use commonly. And probably most importantly, the hardest topic of all is capacity planning and understanding what's actually possible and what's not in this type of environment. I do want to share a little bit of the recipe with you from a config perspective in terms of what we currently understand as the best practice. And then we're going to look at 3 actual arenas, and if you've seen this talk before from me, these are actually mostly new arenas, and I'm very pleased to be able to tell you a little bit about the new 49ers Stadium, for which I'm the principal architect. Most of what I'm going to talk about is in the high density VRD, which I wrote back in 2009, and if you haven't seen it, I think probably a lot of you have, but if you're not familiar with it, and most of the vendors have a high-density VRD now. I think we were the first to actually put one out with data in it, but they're great resources to understand kind of what the recipe is, kind of go through, again, the capacity planning methodologies and so on as a follow-up to what you hear here in real time. And these are free and publicly available. So I'm going to start with, this is actually a short slide sequence that we actually share with our systems engineers for working with customers. And the reason that I'm using this particular version with you, in part just because it's a room of professionals, is also that we found it's really good with expectation setting with customers to talk about the whole process of just getting to a go, no-go decision or something in between based on the cost and complexity of the deployment. In order to properly cover a high-density environment, it can actually be pretty expensive to achieve the coverage and capacity goals that customers have. So given the amount of engineering that you have to do to even get to a BOM or get to a solid design, it can be a lot better to take kind of an abbreviated approach, kind of more high-level approach, which we call the ROM, or a kind of rough order of magnitude strategy, and quickly converge on kind of a ballpark that you can talk about with the customer to say, okay, this is what it's going to mean. You told me you know, 25% of 20,000 seats, right? And you want 500 kilobits or whatever to each person. Well, it's going to, you know, this is what you're looking at price-wise, right? If you want to, if that's not in your range, if you want to step it down a little, then we can go here. And so you have that discussion early before engineers start flying around on planes and doing surveys and so on. It's just in everybody's best interest to kind of get to that quickly. So the basic process that we walk through is it starts with what we call associated user capacity. And we'll get into each of these in detail. And these slides, I think, are going to be available after the conference as well. So associated user capacity really simply is how many devices do I need to get on the network, right? How many associations or AIDs do I need in the environment? And then some order of magnitude breakdown in terms of what we think in terms of 2.4 versus 5 gig and some of the other kind of first order breakdowns. The 2.4 versus 5, of course, is important because that goes to the number of access points that we need. If my coverage is, or if my capacity is weighted towards 5 gig, then I'm going to need more APs because obviously I'm serving fewer people, I'm associating fewer devices on 2.4, right? So that would be an example there. Then we go to active user capacity, and this is the one that's super hard. You know, associated users is really relatively straightforward, right? Every vendor's AP has a certain number of clients that it's capable of associating on a radio. That's pretty black and white, right? Active user capacity is, you know, how much performance, how much goodput can I actually deliver to a typical user in the environment? And that is a number that changes in real time. It depends on how full the venue is. It depends on what interference sources came with the particular event that's performing that day, and so on. So it can be a little tricky. And then, of course, it's gated by stuff on the network side, like the uplink pipe and other typical, the applications that are running and their particular, protocol characteristics and so on. So once we've got basically the output of those two numbers is an AP count, right? Once I have the AP count, then I can go to a layout and make a decision about, okay, what type of coverage am I going to do, overhead, side, underneath, and so on. And from there, I get to dimension the infrastructure, right? Because now I know where my APs are at, so I can make kind of a first order pass about where I need switches and so on. And then I can put a estimated price together. So that's kind of the sequence. And most of this can be done today remotely without having to spend a lot of time on site. Sometimes we do a site visit. It depends on the type of facility. Some facilities, I would tell you that we have a really good understanding now of indoor arenas from 5,000 to, say, 20,000 seats, which encompasses pretty much all the indoor arenas in the United States today. Those we're pretty comfortable planning remotely. If we're talking 70,000 seat football or 100,000 seat soccer, that's probably something that we're gonna look at, right? So it is a little bit venue dependent, but again, the goal is to be able to have this conversation as early as possible, and then once a go decision is made, then we can begin to deploy the resources and dig into it at a much deeper level.
Quick question.
Yeah.
What is the average percent of associated clients that you're seeing in this venue?
Average percent of associated clients, so typically of
for your design target.
Yeah, so most customers were asking for 25% a couple of years ago. So if I had 20,000 seats, I'd be designing for 5,000 associations. Today, frankly, you should be planning for 50%. They may not all be on the network, but we can see on the controller, I can see unassociated clients, right? Potential clients as well as associated clients. And typically in the arena environment, there are 50% of the people have devices, right? Whether they're actually on the network or not.
Like you said, the association is much easier to determine.
Yes.
But the throughput, that seems to be.
Yeah, hold.
Is it looking at applications or?
Hang on to the question, and in a few slides I'm going to get to it, and then you can hit me again if I've left it open. Okay, so if you've seen me talk before, you've heard my bus metaphor. So associated user capacity, again, is a way of describing this that works really well with semi-technical audiences or non-technical audiences, such as we find in athletic departments, I talk about buses, right? So if I got to get so many people to a game, I need so many seats, right, on buses. And an AP is like a bus in the sense that I have a certain number of seats on that AP, right? So our APs, they come configured out of the box for 64 associations per radio. They are software configurable up to 255 per radio, right? And whether you want to do that or not is another question, right? You would never design for the maximum capacity, but we can do that. We support 255 with full encryption and so on. And each vendor will have a specific number that they're working towards, right? So that is the number of seats that are available. But of course, where people get confused is, and you guys are much more generally aware of this than a lot of audiences I talk to, but you know, it doesn't matter how many buses I have. In fact, in some respects, the more buses I have, actually the more difficult the problem gets. I only have so many lanes on the freeway, right? And a lot of the next 50 minutes or so that we have left, we're going to be talking about channel reuse and spectrum reuse. The fact of the matter is, in most typical bowl environments, especially indoors, there's no channel reuse. And let me be more specific about my terminology. So I want to distinguish between what I will call channel reuse and spectrum reuse. Okay? Channel reuse there actually is, because if I have, let's say, 200 APs and I have 20 channels, right, I'm going to have more than one AP on the same channel, right? I'm going to have 10 APs on every channel, assuming an even distribution. So in that sense, I will be reusing channel numbers, right? I'll have more than one radio on the same channel, but I am not reusing the spectrum, right? So as long as those two radios can hear each other and their clients can hear each other, then I'm not achieving spectral reuse. And that is what determines how much capacity I actually can achieve in the environment. And again, I'm going to show you a lot of data, and we'll get into this in a lot more detail. But that's at a high level kind of the broad distinction between kind of active user and associated user capacity. And actually adding more APs reduces capacity in these environments, because every AP that I add is more beacons, right? And it's more just general control traffic and so on. So that actually, in a no reuse environment, that reduces my overall capacity. So I think probably this is pretty self-explanatory given what I've just covered, but to walk through a couple examples. So we typically use, I said that our APs go to 255 per radio, so 510 per AP, but we do not recommend that you plan for that. You may see actual APs in your deployment that are loaded to that level, but that'll be temporary as a function of the distribution at a particular point in time in that venue, right? But we want to plan for a lower kind of average figure. So the number that I recommend to people is 150 associated users per radio, right? Which is, you know, not quite 2/3 of the capacity of the device, and there are two radios in the box, right? So 300 would be the planning figure, assuming again an even distribution of the two. So I take my seating capacity, and a couple of simple examples here. These three sizes are really common sizes, right? So a lot of university arenas and amphitheaters, performance halls, for example, are in the 4,000 to call it 8,000 range. A lot of hockey and basketball arenas are in the 15 to 20 range, right? And then actually 75 is kind of a upper middle figure for American football, right? So these would give you kind of AP counts in the bowl area, and then we have to worry about the concourses and the other kind of the common areas. So those we're going to plan with a more typical kind of average distribution. And this is, again, this is just to get to that ROM, that kind of rough order of magnitude for discussion. these have to be placed by an experienced engineer, right? Ultimately, someone has to stand there and say, yeah, you know, there's columns there and there, or, you know, I don't want to be by that door because I don't want this AP audible in the bowl if I can help it, and so on. But at this stage in the conversation, we're just trying to get to again, that kind of a rough ballpark estimate. So we've done our associated capacity, we've done our active capacity. Where am I putting my APs? So there are basically three ways that you can cover any kind of environment, from overhead, from the side, and from underneath, right? And I'm going to show you examples of kind of all three during the presentation. And I want to stress that these are just tools in your toolbox, right? And you're going to use a different tool in a different venue based on probably the age of the facility, the budget that the customer has to spend, the the nature of the facility, how it's laid out, and how much physical isolation there is of one area from another. And you may actually combine the strategies in the same venue, and I'm going to show you some examples of that as well, in order to try to at least achieve some level of spectral reuse where it's possible. I do recommend regular layouts. I am not a fan. I like to talk about the circular RF firing squad. There used to be a very common strategy of, you know, put the antennas up high, shoot down from behind, right? And the problem with that is, you know, even if you can get really clean antennas, right, which is frequently not the case, but even if you have really clean antennas, it's not, you know, when you go outside the 3 dB points on the antenna, it's not that there's no signal, right? It's just a decreased amount of signal. And depending on the distance and the geometry of that pattern to the, you know, when it hits the ground or when it hits users, you can have a very usable signal, and certainly you can have a signal that's strong enough to trip the .11 CCA threshold and affect my reuse, right? So really important to understand, you know, when Matthew was talking about nulls, for example, that's not zero. And it's sort of like low energy and Bluetooth low energy. It's not low energy on the air so much as it is low power draw from the battery, right? So we need to be very clear about what some of the terms are that we're using. In this case, the reason I recommend regular deployments is we want to have, first of all, clients like to have a really regular uniform signal environment. So from a roaming perspective and a client decision-making process, it's helpful to them. And it can be helpful to some of the infrastructure products in terms of making some of the decisions that we need to make to optimize the environment. Just some quick examples. This is a Plcocell, which is the term we use for the underneath deployment, but it's above the floor type deployment. This is a Pico under concrete, using in an indoor arena. This is a Pico through the concrete in a baseball stadium. And this is overhead, actually in the same baseball stadium, and I'll show you on the next slide how they work together. But this is that kind of overhead shoot from behind, you know, steep down angle to try to minimize the hit across the field, but there certainly is a hit across the field. So these are all valid strategies, and you're going to mix and match the strategies, right? And sometimes more than one will be appropriate, and it'll come down to personal preference and budget. And other times, really only one strategy would be appropriate. So it's, again, until you stand there and actually see the structure, it can be hard to know. So here's a good example of the combining. So this is what we did at Turner Field in Atlanta. So there's actually 3 different blankets that we're using. And the idea here, so we were, for various reasons, again, had to do with the owner of the structure and the company that was actually funding the network. It was important to them to actually do that overhead shoot from behind thing. So that was fine, but I certainly didn't want 3 decks of that, right? The basic plan here was do the 100s that way with a steep down angle, do the 200s shooting back the other way entirely, right, and try to leverage the natural pattern of the antenna to give me some reduced exposure to interference or interference rejection, and then do the pico up top. So they're all basically pointing away from one another. They're as orthogonal as I can make them. And actually, if you look at the AP SNR data, you'll actually see that all three of these strategies perform quite differently. The strategy in the bottom, there's a lot of AP interaction across the field, as you'd expect, right? And you can actually see it. The middle strategy, there's some AP interaction, and interestingly enough, antenna pattern plots are actually real things, and the side lobes and the rear lobes actually do matter, and they are they are physically real phenomenon that do affect your network design. And what's really interesting about the second blanket is when you graph it out, the AP connections that you can hear in the back line up exactly with the pattern plot, the rear lobe and the pattern plot, right? So that's kind of cool. And then the upper deck, as you would expect, we actually have, and it's this picture. This AP can only hear the next two APs next to him, and that's it. He can't hear anything further away. And part of the reason for that is there's concrete and so on. We're also leveraging the curvature of the structure, right, which is giving me some isolation and just sort of the geometry through the deck. The downside to this approach, and we've been, the through concrete approach is one we started with a while ago. It works sometimes, it doesn't work as well other times. It depends on the nature of the concrete, how old it is, how much steel there is in it, and what's on the other side. What devices are we trying to talk to? So it works really well in 2.4. It can be a little trickier in 5 gigahertz, again, depending on what's in the concrete. So, channel capacity. So hopefully we'll get to the question you were starting to ask before. So let me start with just some actual measured data, and this is data that's in the high density VRD. So there's basically 4 different variables shown on this slide. This is aggregate channel capacity, and this is what we call a scaling test. So we're starting with a small number of clients, and then we add more clients. The data is taken with Ixia Chariot. This is lab data, so I am in a relatively pristine radio environment. I've got no co-channel interference or adjacent channel interference. So these are best case numbers, right, would be the comment to take away from this. And what you see is, so let's start with so the red bars are 5 gig, the green bars are 2.4, and the reason these are different is that the 2.4 actually, the 2.4 tests have a mix of clients. So what we don't, we have to contend with 11B and legacy clients in the 2.4 environment, and there are legacy clients in this test as kind of a background load, if you will. And that brings down the average performance in the 2.4 band, even before we get to Bluetooth and all of the other kind of sources that we have to deal with in that environment. But on the 5 gig side, you can see that so I've got 2 stream laptops, single stream phones, and right away, that's a pretty big difference. So coming back to expectation setting, right, we as an industry have done a very good job of educating customers about 300 megabits per second, now 450 megabits per second. Tomorrow or today, depending on how you're counting, it's now 1.3 gigabits per second, right? But those data rates are maximum data rates for multi-stream devices, right? But we are designing for the devices that are in the environment. So what are those? Well, in a stadium arena type environment, and even in a lot of university lecture environments, I know we have a lot of university customers here. I mean, there's a lot of tablets, right? So the phones and the tablets today are predominantly one stream, right? So the maximum single stream rate on an 11N device is 72 megabits in a 20 megahertz channel, right? So that is what I'm working with at a PHY level, not 450, not 300, not not these multi-stream numbers. So when we're doing a lot of expectation setting early in the process with the customer, because there's a lot of unrealistic, people just don't know any better, right? So I had a customer 2 weeks ago that they wanted 2 megabits per user for 10,000 users or something in the room. And you just do the math, it's not physically possible, right? So part of the reason we actually wrote the book and did the lab research was to put a stake in the ground so that we could enable our engineers and our partners and so on to have this discussion with their customers, right? And educate about what's possible. And also, by the way, to help the IT folks at our customers have this discussion with their management, right? So we're setting expectations all the way along the chain. So that's the first thing is which am I playing for? So basically it's the dark red bar is the aggregate capacity. And the next thing you see is that the capacity decreases from left to right. So what's that about? Well, that is the contention premium, right? What you're seeing is that as I add stations to the environment, I am increasing the amount of control traffic on the air and the CA process, right, for gaining access to the medium. And so capacity actually decreases even in a perfectly clean lab environment as I add stations to the channel, right? And of course you can imagine in an actual live production environment, this gets really out of control. So the planning values that we use, generally we plan around 50 active users per radio. And so that's giving me in the low to mid 20 megabit per second range. And this is 11N HT20, right? So with AC, single stream, it's going to be a little faster than this with VHT rates. But So a lot of you probably are carrying this thing, a GS4. It's 11 AC capable. It does 80 megahertz channels, so it can do 433 megabit phi rate, right? In an 80 megahertz channel. In a 20 megahertz channel, it does less, right? In a 20 megahertz channel, running VHT modulations, basically I get 25% on top of this in a clean environment if I'm getting the 256 QAM, right? So really important to know what data rates we're talking about, right, in terms of that active user capacity, right? Because I want to make sure that I'm starting with in the right ballpark. Again, stop me if you have questions on any of this. So from here, and I forgot to mention earlier, so we said 150. Go ahead.
So knowing maybe what 2 clients can do, maybe always estimate 1,000.
I missed the second part. What if I know what 2 clients can do?
You know the production clients, you can estimate another 50 cents.
Yes. Yes, I think the question is am I able to plan effectively at larger numbers based on smaller numbers of data? Yeah, so that's really the purpose of the chart, is to, this is real data. So the whole idea is that engineers can actually use this table. This table is one of the most used replicated pieces of content from that book. And I've seen other vendors sort of repeat the same work because it's just intrinsically useful. Yeah, Devin.
Yeah, I think it should probably be mentioned that data will probably be good for another 3+ years while we transition from 11N to 11AC clients.
Yes.
Because until you have an almost purely 11AC client base, that transition period still looks like that data.
Yes, that's exactly right. And even with AC clients, if we're not getting 256 QAM, then it is these numbers, right?
You mentioned tablets before.
Yeah.
I guess most people would assume that in a stadium, the majority of clients would be smartphones.
Yes.
Do you see similar sort of numbers between stadiums? Is there like, you see often 60% smartphone, 70% smartphone, 25% tablet, 5% laptop? What are the sort of breakdowns?
So typically, and it does vary by venue, but the statistics I see on a typical basis, 80% at least of the devices are smartphone, tablet form factor. Really, the only people with laptops in a stadium environment are media or staff, for the most part. So it's a very, very small percentage. Yes.
So you mentioned earlier some of the unassociated clients. You never talked to the venue about the impact of unassociated clients and how to use incentives to get them on the network?
Yes. The question is how do we discuss the unassociated thing with the client or with the customer and options for trying to encourage them to get on the network? So the answer is yes, and this is the subject of a fair amount of active discussion about also things that we could do as a vendor to facilitate that process. Things like Hotspot 2.0, right, which are available now, can capture clients that maybe wouldn't otherwise actively connect to the network. There are other things that we can do from a honeypotting kind of perspective to get those clients out. We do, if I can read between the lines with your question a little bit, do we want to stop clients from probing? Absolutely, we want to stop clients from probing. I'm sorry?
That's the 50% that's eating what you're expecting.
Yeah, absolutely. Now, it must be said that folks like Apple in particular, and I think we have some Apple folks in the room, are doing all they can so there's a desire both from a battery life perspective, I think, as well as other reasons to also probe as little as possible, which can create other problems for us, frankly, because we are now in the location business, as I think our most, or soon will be most wireless LAN vendors. And if you're dependent on probes as your source of measurement for location and the devices are not probing, then you can't locate very well, right? So you need to use other types of traffic and other methods for that. But yeah, certainly reducing the probe traffic is important. Yeah, can't catch a break. Anyway, so let's keep moving. So this next slide is the same data, but whereas, so I always start with showing the aggregate because it can really be eye-opening for some people to actually see, that's all I get. I thought it was more, right, at the aggregate level. So then let's talk per client because this is the next eye-opening discussion. And this is the chart that I see most often copied by other vendors. So the left half is actual measured data. The right half is just interpolated based on that result. And again, 5 gig, 2.5 gig, single stream, double stream. And we are designing to the dark red line, right? So 5 gig, single stream device. And now it's even more pronounced. So all I've done is I took the aggregate data and just divided it by the number of clients. So that's right away you see this is an average value. If you looked at the Chariot output, you would see big swings in numbers, right? Depending on, even with airtime fairness running, right? We're still going to see some variation in the throughput results. But, again, I'm building a case, I'm building up to that active user discussion, right? Active user capacity discussion. So this is my best case number at 50 active users on one channel in an unimpaired environment, 500 kilobits. Best case. So right away when I hear 2 meg per user, right? But you can actually use this chart and have that discussion. So if somebody wants 2 meg, I can give you 2 meg, but then I can only put 15 people on the radio, which means my subscriber target has to be proportionally reduced, right? Which is hard to control, but I can design to those criteria, right? So you can kind of put it back on the customer. Yes?
Sorry if I could just make a point here. So we don't look bits per second, not bytes per second.
This is bits per second, yes.
Because I've had conversations where IT people get confused with things.
Yeah.
You can map it over, so it's 183.
Yes, absolutely correct. Yeah. Okay. So, and as we said, AC is not going to dramatically alter this picture because hang on just a second. The guidance from so I was I think the first person to take a stand, and it was very controversial and still is controversial internally. I have these debates to this day about 20 meg channels only in these environments. But as far as I'm concerned, that remains the guidance. And frankly, if I could rewire, so all the Atheros radios are capable of 5 and 10 meg channels. There's just no driver support for it. If I could rewire those things and do 5 meg channels in HD environments, I'm telling you, I would do it. And if I could persuade Apple to implement it, because you're 60% of my problem in these venues. Yes, well, yeah, I stand corrected, thank you. But so we need more of this sort of working together type environment, because I mean, the high density environment is really where all this stuff kind of hits the road. And I could deliver so much more performance in this environment if I wasn't constrained by some of the implementation choices that have been made kind of all the way around. But anyway, you had a question, I'm sorry.
Are you manipulating power?
I am not manipulating power in these. So I'm running full power. And by the way, the clients are typically going to run full power as well. So for example, so iOS devices will never run anything less than full power, is my understanding. And in general, we see that same type of behavior from other single stream type devices as well, because they want to maintain connectivity. They want to provide a high quality user experience. And as Matthew said, it's, SNR equals data rate, right? So so even though I might be advertising power constraint in my beacons, you should expect that clients are not going to honor the power constraint in the real world, right? Which is one of those features I would love to have better coordination on. Because between that and some other stuff that if we had it in the mobile device, if we had dynamic receive sensitivity tuning in the device, again, I could pack a lot more. I could actually achieve spectral reuse, and I could quadruple or quintuple my good put in these arenas.
I have a question about that. Do you have the ability on your devices to reduce the sensitivity of your radios?
Yeah, the question is, do we have the ability to modify receive sensitivity? The answer is yes. And we use this feature extensively. So even just having it on one side of the equation makes a measurable difference in the throughput in the environment. And actually, all this data originally grew out of some work that we did with some of the firms in New York and Chicago that operate trading floors. And they actually licensed the driver stacks and implemented receive sensitivity tuning on the stacks because of the number of devices they had to have in a very small area. So it actually is very effective if it's on both sides, but you can get some benefit on just one side. Right. So just to reinforce the point about single stream devices, and I put these up here just because some clients don't always believe me. So this is the iPad 3, iPad 4, right? One antenna. iPhone 5, single stream. And the GS4, it's even on the board. It's not a separate antenna, but it's a single stream device, right? Diversity? Correct. They do not have diversity. And so this is part of the problem with the through the concrete strategy, or frankly any non-line of sight. So these devices are really challenged, and it applies to all the vendors, any single stream device. So one of the reasons, so Apple devices get knocked for having shitty radios, which couldn't be further from the truth, because people have connectivity issues. And I'm here to, if you look at the FCC test reports for the iPhones and so on, I mean, they're certified at 21, 23 dBm EIRP. Those are full functional, full power radios in those devices. But in fact, they have difficulty connecting when they go around corners or when they're obstructed, right? And that comes back to diversity. So having a second chain is in high density environments and a lot of other environments is not even about having the second stream. It's about having that additional degree of freedom and letting the baseband do its magic. We get so much processing gain in the baseband that it allows us to make a much more reliable connection over time. So We're assuming a future where the smartphones are basically single stream and the tablets are two stream. We're starting to see that. The new iPad is a two stream device, right? So that's great. I don't know if the phone battery operating environments will permit that, but it would make a big difference in terms of the user experience.
Question about the If that's not an option, let's say I did see temporary conventions.
Yeah.
So that's not an option. We get the functionality of our construction instead of placing them on
Hold that question. I'm going to show you data in just a minute on crowd effect, and then you'll probably have other questions. So let's talk CCI for a minute, because this. So you saw the single channel best case numbers, right? So let's talk spectrum reuse, right? So what is CCI? There's a lot of misunderstanding about CCI. CCI is not non-Wi-Fi interference, right? Where I've got some constant duty cycle video camera that's 5 megahertz blowing up my channel. CCI is other 802.11 validly formatted frames that my radio can hear and decode on the air, right? This is crucial to understand in high density areas. My colleague Peter is in the room. I borrowed his pictures here from, he's got an awesome white paper that kind of gets into this. But if I actually have channel reuse, then, or spectrum reuse, then in these two cells, you can have two conversations at the same time, right? Without sort of a current form of multi-user MIMO. But if they can hear each other, then it collapses to a single channel, right? And what a lot of people don't understand, even people that are clear on this, what they don't understand are, because you really have to be totally geeked out to go to this level of depth. But so where does it trip exactly? Where it trips is in the CCA, right? And the preambles, no matter what data rate your payload is at, the preambles per the standard are running at 6 meg. What does it take to decode 6 meg for SNR? 4. That's it. So my interference radius for 802.11 CCI is a really, really, really long way. And you can actually compute it pretty easily, right? What do we design to? Neg 65, that's industry best practice, right? What is my rule of 6, right? Every doubling of distance, I get half the power. Or sorry, 4 times the power, right? So if I'm planning for R here, and I'm at neg 65, then I'm at 8R, and I'm not even in a line of sight environment. I'm still interfering. I'm still tripping the CCA over here. And this is why even football and soccer fields are a lot of times a single collision domain, because they can hear each other. And again, the radios are actually a lot more powerful than people think. An easy test that you can do to actually prove to yourself how awesome the radios in iOS devices are, take your iPhone, whatever model, put it in tethering mode, and take your iPad, go outdoors, and do a rate versus range test, right? Just fire up speed test, just fire up Ookla. You don't need anything fancy for it. Just every 50 feet, just do a speed test. And so I've done this, and you can keep doing speed tests for almost 600, 650 feet, and still maintain multi-megabit throughput on Ookla, right? So pretty powerful stuff. So this is really the problem we run into in these environments. So, okay, I know what the capacity of channel is. I know I have one single collision domain. So now I need to roll that up into some aggregate value, right? Well, so the next logical step is how many channels do I have? That, of course, varies by country. This is one of the charts in the VRD. So in the US currently, and this has changed, so since this chart was published, we got 144, right, as part of the AC improvements. And there's actually been originally there was going to be 4 channels. So we actually, for those of you who don't know, we actually lost some channels due to some questionable deployment behavior from some outdoor integrators. Anyway, we have 9 channels. Those are the gray channels that are non-DFS, and we have a number of DFS channels. So on balance, I mean, just rough numbers, I use 20 channels when I talk to people about this. Yeah. Yeah, so is it safe to use DFS channels is the question. The answer is absolutely, positively yes. And the cost of not using them vastly outweighs the potential cost of using them. Yeah, what we're talking about, so sorry, for those of you who can't hear Chris, he's saying is what about client support? We're talking about the exact same thing. So, and I've got, let me just jump to that. So this is my guidance on DFS channels. You have to use them. There's just no way not to use them. iOS device. So you can break the world into 4 categories of devices: iOS, macOS, Windows, and Android. Right? Of those, only Android does not do DFS channels reliably, and the new ones do. So anything that's AC capable does DFS channels. Right? Now there are complexities to using the DFS channels, like he's not going to be probing in the same way that he probes on a DFS channel, or a non-DFS channel. So that might affect location and so on. But the working assumption in these high density, particularly the arenas and so on, where I have enough AP coverage, is that even if I've got a client that can't do it, he's gonna have an AP at a reasonable signal SNR that he can get on. So as compared with deploying and not running the channels, you're going to deliver a lot more aggregate goodput here. And another way to think about it is you're actually getting DFS capable clients out of the way of the non-DFS clients. Yeah.
Do you have a quick way to tell when you're getting the radar hits and switching off the channels? That's one of the problems I've had with some customers. Using the DFS channels, they need to have some way to know which ones go to because it's just a persistent signal. But it would also be useful to know which ones occasionally hit and when they're hitting so they can add dynamic.
I'm not completely following. Are you talking about the AP side or the clients? Yeah, so I can speak for our equipment. So the radar changes are called out in the, there's a couple different commands you can run that, it'll show you, like if you run the ARM history and ARM changes channels because of a radar event, that'll be flagged in there and you can tell. But I must tell you, so part of the reason for my recommendation is we've been looking at this a really long time, and we see very, very, very few DFS events. And I ask a lot of people about it. You may, if you have a different experience, speak up. But I mean, there's certain, like marine environments, sure. Lower Manhattan, sure. I got an email from one of our SEs. We've got a bunch of, we're on the Corniches and a lot of the Middle Eastern cities on the Red Sea and so on. And one of them, it's like tripping all day long. But that is so much the exception. The vast majority, in my day-to-day activities, I see a radar hit once or twice a year. The radios are really good now. It's not like the first generation of the NAPs where the DFS and TPC requirements were basically laid on us retroactively, right? And the silicon was already built, right? So we had a lot of false positives. We're multiple generations past that now, and the radios are, for the most part, really, really good about this kind of thing. And the FCC testing is actually pretty rigorous as well. So the chips have to be capable of discriminating. Yes? The question is, do I recommend DFS when there are real-time applications? The short answer is yes. Once you're on the, so my assumption is you're on the network. So that part can take longer on a DFS channel, but once you're on the network, you're on the network, right? So unless you are in a channel flapping environment, it should be, for all intents and purposes, just like any other channel. Yeah. Okay, so moving on. I gotta actually fly here. So let's pull this together. So here is just a calculator for how much bandwidth, and I'm showing 2, 3, and 4 reuses, but the fact of the matter is we only ever get 1 in most environments without very, very specialized engineering. So this is my aggregate system capacity. And you can take those numbers and divide them by the device counts, and here are just a bunch of random scenarios. And this is what you get. So if you're planning video in these environments and you're thinking I'm going to do 1 meg streams, you might want to reset your expectations. And what's so interesting about these numbers is that these consistently, I mean, we have our own venues we look at, but I noticed Extreme put out some numbers yesterday or the day before about Super Bowl, and if you dig into those numbers, so they talk about 50 megabits per user per hour. If you divide by 3,600, right, so per second, you're down here. So, and the Cisco numbers we've seen for some of the stadium, some of the events that they've published, we're all seeing approximately the same experience in these environments. So again, it just reinforces this idea that the radio is radio. It doesn't matter what vendor you're using from a propagation perspective. Now, vendors are going to vary on other features, but these are the kind of numbers that you need to be planning against. I'm talking about spectrum reuse. Okay, so I'm going to, just in the interest of time, I know everybody wants to see examples, so I'm going to skip over the config recipe. If you want to talk about I'm here all 3 days, and I'd be happy to go through this with you. So just chuck@arubinetworks.com, you can email me or just catch me here. So Aruba's been selected to provide the infrastructure at the new 49ers stadium. This will be the highest density football stadium ever deployed. You can think of the design as a bullseye. It's a concentric rings. And again, that my point earlier about the different using different coverage strategies in the same facility to try to increase isolation. So the bowl, we're using Underseat Pico, and I'll show you pictures. The concourses, we're using kind of a down tilt. Actually, I have a really boring animation for this. Sorry for the PowerPoint crap, but that's the bowl using down directional down tilts in the concourses, and then the exterior, the perimeter is out. So again, they're all aimed orthogonally to try to minimize the interference as much as possible. That's the main bowl. It's a little dense. That's the concept. So we've custom built an enclosure with a strike plate to protect the box that clamps to the rail system that's being used. And I've got 650 cores through the concrete. These were the cores before they put the rails in. And now each of these is an access point, or will be. Now I'm not running full power here. The whole bet is we're going to run at 0 dBm, and I'm going to ride the curve, right? So the goal is to deliver that 25 plus SNR experience to the clients localized by using very little output power on the APs. And this is the rear and the penetration. So that right now it's a construction site. It doesn't go live for 8 months. So we just got the enclosures and they just got installed. So that's the top half of the enclosure. The bottom half with the AP has not been installed yet, but the cables are through and they have to terminate. And then in the concourses, you have, you'll note the arrows. So this is walkway. These are concessions and restrooms. So I've got APs up high pointing away, and same thing on the outside. And here's a picture. So again, pointing away from the field. It's not perfect. They'll be able to hear the field to some extent, right, and vice versa. I'm just trying to reduce the, I'm trying to get rejection where I can, right? These are the enclosure combos. There are about 8 different AP variations that are being deployed in different parts of the stadium. In general, we're doing, where we're using directionals, We're just, I went with metal boxes so we could just screw it directly on. Again, aesthetics are important, small form factor is important. There's just a very small number of these, actually. Most of them are like that.
I had a question. Did your design for this include anticipating events that would use the field, like a concert or anything that would have seating where the football is?
Yeah, so there is no discrete field coverage, but there is tremendous coverage from all the way around. So my expectation, my first answer would be I would rely on bleed coverage. If that turns out not to be sufficient, we'll address it. We've got a couple ways we can handle it, but as it is, I'm over-covered, as you can tell, right? So, and some percentage of these radios are going to end up not being on, right? We don't know which until I fire it up, and I only get one chance to install, which is why you see so much here. So anyway, I am way over my time, and I appreciate everybody. Yes?
I don't know if you can do it quick, but do you do anything with minimal data rate?
Yeah, so I skipped over the recipe, but here's the, come on. So this is our rate structure. Yeah. So now what we do at Levi's may be different from this. If I can trim more, I'll trim more. I may be able to trim more, we'll see. But this is what we're running in most arenas today. So nothing lower than 18. And the only reason the 11 is there is because I get, there are clients that really will puke if the 11 basic rate is not there. But we don't want to offer 11B service, obviously. But that's a user satisfaction issue. So, and again, I can meet with, if any of you would like to discuss this more in person, again, just hit me up and we can go through it in detail.
Being that this is California,
yes.
did the health concern issue come up about people sitting on access points?
Health concern has not come up. What I tell people, well, so as you saw in the picture, there's actually a certain amount of space. So we are required by the FCC, there has to be 20 centimeters, which this design provides for. So we are well within the, what's called the SAR rates. But if you're concerned about that, then the phone that you have, the Wi-Fi radio specifically that you put up against your head is a bigger problem. Yeah. So. Yeah. Yeah. So thank you very much.